Okay. So the next thing that we are going to do is focus on the circuit building component 2 of experiment 7. We'll start with part A. The proto board should be one of your views, and you can selectively make it the larger view or the smaller one, depending on where we are in terms of our conversation. Um, right now, I want to talk about the lab write-up. So in the lab write-up, we have a circuit diagram, the logic diagram of a few gates. This is a 2-input NOR gate 7402. We have a 3-input NAND gate 7410, and we have a NOT gate, an inverter in 7404. So we are using three different chips, and we are controlling the inputs of these chips by using digital channel 0, digital channel 1, digital channel 2, and then the outputs are observed on digital channel 8, 9, and 10. So far we have been using oscilloscope, wave generator for analog inputs and outputs. However, these are digital inputs and outputs. So we need to look at digital I/O. And the analog discovery actually provides us with 16 digital I/O pins. So if you have access to analog discovery, or you remember this from before, you might remember this. So all the oscilloscope and wavegen and those functionalities were all the way on the left side, but we never really used all the digital I/O. The digital pins, there are 16 of them, 0 through 7, 8 to 15, and they have colors like pink and green and purple and brown. We have not used them until now, but because we are dealing with digital inputs and digital outputs, we are going to be using that for this particular experiment. So what I have is, so for example, if you look at the schematic, and if you look at U1A, which is the 7402 chip, pin number 2 of that chip should be controlled by an input of digital channel 0. So what I can do is take a look at what that digital channel 0 is. Well, digital channel 0, it looks like the pink color, digital I/O signal, and I hope you guys are able to see that. Um, so digital channel 0 is right here, 1, 2, 3, and so on, and then 8, 9, 10, and so on. So I could configure this as an input, or I could configure this as an output. It really depends on me, the user. But I have 16 of those options. Um, for right now, I'm going to configure it as an input, digital channel 0 as an input, because in my schematic, I have digital channel 0 on the input side of that particular chip, and so on, right? 7410 also has digital channel 0 as one of its inputs. It has digital channel 1 as one of its other inputs, and then digital channel 2 as well. So 0, 1, 2 are going into the 7410 chip, which means I have pink, green, and the purple wires going into uh, that chip. And similarly, I observe these outputs on digital channel 8, 9, and 10. Now, I recommend that you use a logic diagram such as shown over here to build a circuit. However, having taught this course several times, I usually notice students looking at a picture like this or a picture like this to build a circuit, which I highly discourage. I want you guys to be building the circuits by looking at circuit diagrams or logic diagrams and not pictures, because you could easily miss a lot of detail in a picture that is taken in a not so good angle. So I'm going to be using this to build the circuit. In fact, to save time, I've actually built it, but I'll walk you through it. So let's see. I bring the protoboard back into view, and I will try to zoom in a little bit more, and I hope that is a good view. uh, I don't know if that light makes it better or worse. You guys should tell me uh, if the light is a better option or not. All right, so it looks like no light is the winner here, so let's go with no light. So let's start at the top. How many chips do I have? I have got three chips: 7402, 7410, 7404. Each of these chips is going to be a 14 pin IC. I have put those chips in that same order from left to right: 7402, 7410, 7404. Each of these chips requires power and ground. So power is going to be on pin number 14, ground is going to be on pin number 7. So as you can see, these red wires that go to the top rail over here, those are pin number 14 of three of those chips going into the power rail. I've used this red wire coming from analog discovery to give power to that particular top rail. And similarly, I've got three black wires going from pin 7 to ground, and I'm connecting the ground from analog discovery over there as well. So that's how I make those power and ground connections, which do not appear in the logic diagram, but should be made in order for the ICs to be operational. Next, I'm going to look at pin number 2 and 3 of 7402 and connect the wires, digital channel 0 and digital channel 1, to them. Those are colors pink and green. So I've taken a pink wire, although in the middle I have a different intermediate color because I have a separate wire to go from the analog discovery to the proto board. That's why you see a difference in the color. But believe me, it is digital channel 0 and 1, which is corresponding to the pink and the green colors on the analog discovery pinout. So those are going into 7402 chip. And I noticed that that particular digital channel 0 is actually controlling the inputs of the other two chips as well. So what I did in the proto board was I used wires to connect. Okay, all right, this is probably better. So that's my chip 7402, that's 7410, and that's 7404. So I took the pin number 2 from here, connected it using a wire to pin number 1 there. Pin number 3 from here is connected to pin number 2 there. Pin number 1 from here is also connected to pin number 1 there. So that way, by using those three connections, I have essentially mapped the input to multiple inputs to those chips so that I don't have to keep switching back and forth between the inputs. I'm also monitoring the output of these logic gates on digital channel 8, 9, and 10, corresponding to colors pink stripe, green stripe, and purple stripe. So those are also connected on these chips as well. So pin uh, 3, for example, pin 1, sorry, pin 1 is connected through that blue wire for that guy. Pin 12 is connected through this green wire for this chip, the middle chip, and then pin 2 is the green wire of this chip connected to those specific channels. So that's how I make the connections. And for everything to work, the first thing that I would need to do is to turn on the power supply, because that gives it voltage to be operational. So if you guys can go back to your view in which you see the um, two things. One is the analog discovery waveforms and the IC. So switch to the view in which you look at waveforms and experiment 7 write up. make that your main view. Um, so I've got supplies and I've set the positive one or the red wire to plus 5 volts. I don't need the negative one, so that is off. I'm going to turn that on. So once I turn that on, I can use those chips to do that desired logic function. And I monitor that by using static IO. If you go in that welcome field, there is a static IO option. So far in the course, we have been looking at scope, wavegen, voltmeter. Now we look at static IO. And as you can see, static IO brings up this particular page in which there are 16 options in which I can configure any one to be an LED, which is going to be an output, a button, or a switch of several types. So you can either configure this as an input, a button or a switch, or you can configure this as an output, so an LED. In my circuit, I need channel 0, 1, 2 to be inputs. So I have connected channel 0, 1, and 2 as switches that can toggle between 0 and 1. So switches that can either be 0 or 1. And for outputs, I have 8, 9, and 10. So just for the sake of uh, convenience, what I'm going to do is I'm going to look at the names of these channels and change those names so that it is easier for me to read and follow through. So digital channel 8 is actually the output of 7402 chip. So I can make that 7402, 7402 out. So I'm going to call this 7402 out. This can be 7410 out, and the next channel, channel 10, can be 7404 out. And then this is simply going to be digital channel 0, digital channel 1, digital channel 2. Alright, so those have been set up. Let us start with all zeros because that's the good. So I'm going to make all of them 0 here, and as you can see, as I'm changing them, the LEDs have started lighting up. So let's try to check whether this is operating as expected. So let's start simple. 7404 is the NOT gate, and it is connected or controlled by digital channel 0, and the output is on digital channel 10. So 0 is right here, 10 is right there. So when 0 is uh, digital channel 0 is 0, the light is turned on. So that's an inversion operation, which is good. That's what we expected. And as I go on and off here, you can clearly see that digital channel 10 is exactly the opposite of the state of the switch 0. Don't let digital channel 8 confuse you, because that is essentially that is the output of the 7402 chip, which is also controlled by digital channel 0, and it is just happens to change. But we are right now trying to validate our connections for 7404, which looks like it is working. Next, let us look at the NOR gate. The NOR gate is controlled by digital channel 0 and digital channel 1 as the inputs, and the output appears on digital channel 8. And how can we describe NOR gate? Well, I can describe OR gate by saying the output is 1 when at least one of the inputs is 1. That's OR gate. So for a NOR gate, I should say the output is 0 when at least one of the inputs is a 1. So the output is 0 when at least one input is a 0. one, one or one. So digital channel 8 uh, right now is, so both inputs are 0 0. In this case, channel 8 is on, but if I have any one of them go on, it could be this guy, it turns off, or it could be this guy, it turns off, or it could be both, it turns off. So that's a quick check on NOR. The last one is a 3 input NAND gate. So for NAND gate, what do we have? We have, for AND, we say all inputs need to be true in order for output to be true. So for NAND, I would have to say all inputs need to be true in order for output to be false. So channel 9 is the output. These are my 3 inputs. And as you can see, any combination, you always have that light on. The only option in which that light turns off is when all 3 inputs are 1, which it does here. So that sort of shows that um, all these 3 chips are working as expected, and I've gone through them um, and validated each of them step by step. Now I've captured all of these results into a document and I've posted them on Piazza for you to download and use in your report. You obviously need to still analyze these things. I'm just going to pull up the document here so that I can show you. So I've done this for 7404. I've done the truth table here, 7402, which is a 2 input NOR gate, and then a 3 input NAND gate. So I'm showing all the 8 possibilities here. So the thing that we demonstrated live has the pictures have been captured and posted on Piazza. Okay, so that completes part A. We are going to start talking about part B, the experiment on JK flip-flops in the next class. Now, in the next class, we are going to have some very exciting topics. We are going to be talking about counters. We are going to have very engaging experiments going on. And when we start talking about 555 timers, that's when things can get very intense. And I would really encourage you guys to be a part of that lecture. So the next 2 classes are going to be very interesting, at least to me. All right, let's stop the video and take questions.